Hi guys, welcome back to another video. Today we're going to be looking at the following Mathcounts problem that tests our knowledge of optimization. And so let's start with a quick read. So the integers 1 to 16 are placed in the 16 circles in the figure shown, with each number occurring exactly once, and so that the sum of the 6 numbers around each hexagon is s. And we're asked to find the greatest value of s. So if we kind of look at this, right, just to understand the problem, it seems like what they're saying is we have these 4 hexagons. So let's say we have this red one right here, right? So we have hexagon 1, and let's do this blue right there. If we do green right here, and then lastly, let's take purple down here. So we have these hexagons, right? And when we add up all of the circles, each one has a sum of s. Okay, so that means all 6 vertices on all the hexagons add up to s, and we want to maximize s, right? So the thing to note here is that some of these vertices are used in only one hexagon, right? So like for example, this black vertex right here is counted once in the red hexagon, right? But for example, if I take this dot right here, this circle, I'm using it 3 times in the blue, the green, and the purple hexagon, right? So the idea is just common sense tells us that if we are trying to maximize s, we want to use our biggest numbers in the places that they are counted the most, right? So for example, if I put a 16 here and a 1 here, that wouldn't be maximal because now I'm using 1 in 3 of these hexagons. But if I reversed it and put 1 out here and 16 here, I'm increasing my sum by so much more because now 16 is used in all 3 of these hexagons. So this basically gives us kind of the inspiration for how we want to solve this. So if let's say we get rid of all of the markings, and basically, let's say this is A, let's change the thickness. So we have B and that point's A, right? Because these two, so basically we have A and B are counted 3 times. They're in 3 hexagons. Now let's see, how many are in 2 hexagons? So I have, let's say C, D, E, and F. So C, D, E, F. These are counted in 2 hexagons. And then the other 10 points, and let's just make sure it's 10. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So then I have, let's say, G up to whatever letter, right? G onwards, and these are all counted once. So this tells us if I were to add up all of the hexagons, right? That's obviously 4s because it tells us that each hexagon has a sum of s. So if I add up the numbers around each hexagon and add up all 4 hexagons, I get 4s. But now in terms of our letters, I basically get a plus b. So a is counted how many times, right? A and b are both counted 3 times. So I could say 3 times a plus b. And then I have plus 2 times c plus d plus e plus f, right? And then I have plus g plus onwards. And just kind of explain this a little better. This right here tells us how many times each vertex was added, right? So A and B were counted in 3 hexagons, and because we're adding up the sum of all of our hexagons, that just means that we have 3 times A plus B, because A plus B is counted 3 times in our total sum. And then similarly, C, D, E, and F are each counted twice, and then you have the rest of the letters. Okay, and now 4s, we're trying to maximize 4s, which means we want to maximize this expression. And so how do we maximize this? Well, common sense just tells us I want to use my biggest numbers the most I can, right? I want to maximize how many times I'm using the biggest numbers. So that means I would put 16 and 15 for A and B, right? Because then I get to multiply these by 3. And just kind of logically, if I put 16 and 15 in the set that's only counted once, and if I put like 1 and 2 here, so instead of this coming out to 93, I'd get 3 times 1 plus 2, which is just 9. So this big of a difference is why we want to pick our biggest numbers to be multiplied by our biggest numbers. And so basically now we kind of just work backwards. So we have 3 times 16 plus 15, then 2 times, and now we want to pick the next 4 biggest numbers. So 14, 13, 12, 11. And then we have 10 plus 9 all the way to 1, right? We just use up the rest of our numbers. And we just have to simplify this now, right? Because we know that this is equal to 4s. So let's see, this is 3 times 31 plus 2 times, what is that? 50 plus 10. So the sum of 1 through 10, that's 55. And one way you can do that quickly, 10 times 11 over 2, right? That's just a quick, easy way to figure out the sum of the first and consecutive numbers. But anyway, so this is equal to 4s. So we have 4s is equal to 93 plus 100 plus 55, which is equal to 248. And so now dividing both sides by 4, we get s is equal to 62. And let's just go back to the problem, make sure we're answering the question. They're asking for the greatest possible value of s, and we did everything we could to maximize s, right? And this maximization just came from us giving the biggest values to a and b, and then c, d, e, f. So ultimately you get s is equal to 62, and that's your final answer. So that should be all for this question. If you have any questions on our solution, please leave a comment. And if you enjoyed the video, a like and subscribe really helps us out. But that should be all for today. So I will see everyone tomorrow for another video. Thanks for joining.